just so you guys know. But yeah. So Christy and myself, Amanda, are two of the peer advisors here to present one of our distinguished faculty members today. We want to give a warm introduction to Assistant Professor Hannah Hausman. Today, she has joined us to discuss the realities of research, how to see herself as a researcher, and her work within her Learning and Memory Lab. So thank you so much for joining us today, Professor Hausman, and we are all excited to learn more about your work.
Thanks so much for having me, y'all. It's really exciting to talk to you. So I'm going to tell you a little bit about what we do in my lab. And I know there's a time for question and answer at the end, but if you have something like highly relevant, like you just need clarification as we go, feel free to put it in the chat or raise your hand. But otherwise, if it's a bigger picture question about research, just wait till the Q&A part at the end. All right, I am going to share my screen with you so you can see some of the stuff I want to show you about doing research. And I'll tell you a little bit about myself too. Okay, let's start with this one. Je m'excuse. Go. You'd think after years of this, I would have it under control. View. There we go. All right, so I'm just going to give you a little trajectory of at least my professional life. Yeah, I mean, I guess if you want to know anything about my personal life, I'll tell you too. But all right, so let's start with undergrad. So when I was an undergrad, I did my bachelor's at a small liberal arts school in Western Massachusetts called Williams College. Yes, our mascot was this cow. We were the Ephs, named after the founder Ephraim Williams. So we were in fact the purple cows. And when I was doing my bachelor's, I actually focused on math and statistics rather than psychology. Although I did take a couple of psychology classes, like I took intro psych and cognitive psych, but for the most part, I was really focused on those two majors. And then after I graduated, I got a job as a statistician at a place called the Carnegie Foundation for the Advancement of Teaching, which is actually over the hill in Palo Alto. That's a picture of Palo Alto. And what I was doing there was actually working as a statistician, but the organization as a whole was trying to improve education. It's an education research nonprofit. And there were two main projects, and one of them was trying to keep new teachers, like, teachers in their first year of the job, in the job longer, because at the time, about 50% of new teachers left that job after the first year. And so we were trying to solve that problem. And then the other issue we were working on was trying to improve the math classes and math instruction at community colleges around the country. And that's the project I worked even more on. But my job was actually just being a statistician. So I just analyzed data, made graphs, gave presentations, and it was actually incredibly boring, even though I love statistics. It was just like, if you've written the results section or something for like, let's say research methods, it was that every day of my life. And so that got a little dull. And while I was doing that, I realized, although I loved statistics, what I was way more interested in was the actual like content side of it. How can we help teachers be more effective? How could we change the curriculum in community colleges to help students learn more in their classes? And that's what helped me realize that I needed to make a change of what I was studying and what I was going to do in my career. And I ended up going back to Williams to work as a full-time lab manager in a memory lab. And that was fantastic. So I wasn't taking any classes or anything. It was just a full-time job where I was essentially being an undergrad research assistant, except for it's a small school. So I was the only one. So like I was doing, and there are no grad students, so I was kind of doing what a grad student would sort of do, but also what undergrads would do. So it was a little bit different of an experience than you'd see in a lab here, but it was great because it introduced me to so many, so many interesting ideas about doing memory research. And it also just helped me learn so many skills super quickly because I had to do everything and I had literally no idea what I was doing because I majored in math and statistics. So I learned a lot really quick, and I was fortunate to have a mentor who was patient and helpful with me, and hopefully I was helpful in his lab as well. And so then after that, I got my PhD at Colorado State University in cognitive psychology. I'm originally from Colorado, so it was nice to go home, but also it was just a fantastic place to do my PhD, mostly because I loved my PhD advisor, who was a really helpful mentor. And again, he just like, although I learned a ton being a full-time lab manager, there's always so much more to learn. But again, my advisor was just really patient and helpful and helped me figure out what I was already doing well and how to capitalize on my strengths, but then also learn how to improve in the areas that I needed to work on. So for example, he really helped me with writing and things like that, and helped me with networking and all those things. So that was great. So then as I was doing that though, partially out of my interest in education, I also took on some summer jobs and even some side jobs, which I wouldn't necessarily recommend trying to work and do a PhD, but nevertheless, here we are. So I also worked in the central office of Denver Public Schools. I was helping elementary schools and middle schools that were on a turnaround plan, which is just the polite way of saying that their schools were about to be closed if their students didn't start doing better. And in that job, I was mostly being a statistician. I wasn't really doing much with the schools. I was really just analyzing data. But then I also took on a job as a consultant for High Meadows Graduate School, which is a teaching program in Massachusetts. It gives middle and high school math and science teachers their master's degree and then their teaching certificates. They can teach middle or high school math or science. And so in that job, I did a lot of training new teachers on principles of learning and memory and how to translate that into their teaching strategies and their assignments and things like that. And even though I loved working in schools specifically, I really wanted to make sure that whatever I did after my PhD, I'd get to enjoy doing research, but also still keep teaching. So that's how I ended up here. If you like doing research and you like teaching and you never want to leave schools like me, being a professor is the most fantastic job in the world. I get to do all those things and I never have to leave school. So yep, so now here I am. And excuse me. And yeah, now I'm an assistant professor and my focus is cognitive psychology with my lab research is learning and memory. So that's kind of how I got here. Not planning on going anywhere. This has been a great place to be. And I've had just some of the best students I could imagine. And some of them I even saw come into the event today. So thanks to my students for coming. All right. I just want to give you a little bit of explanation of like what a lab usually is. Maybe some of you already know this, maybe you don't, but I just want to demystify things because I didn't know anything. Like I just didn't even know like what a PhD really was. So how labs are generally set up is in, a triangle, if you will. You have in a lab, you would have a principal investigator. That's like the person who's the professor. There's me. Clearly, I have a favorite color. I'm wearing dark purple. There's dark purple. I'm wearing dark purple. My hair's dyed dark purple. So, maybe I need to take a look at my fashion choices, but nevertheless, there's the person who's the principal investigator of the lab. Then there might be people who we call them postdocs or postdoctoral fellows. Those are people who have already gotten their PhDs, but they're not a professor just yet. So they don't teach or anything like that. Usually their job is mostly to keep doing research. So it's a chance for them to do research without all of the extra burdens of like too many meetings and prepping new classes and things like that. And then helping those people are the graduate students. And, it varies a ton lab to lab, how many there would be. But usually if there's one postdoc, there might be 3, 4, 5, 6 grad students kind of thing. So that's why the triangle's getting bigger and bigger. There's more and more people kind of at each level. And the grad students are the people earning the PhDs. They're doing research, taking some classes, and also often TAing. So a lot of you have had your TAs in your sections are those people getting the PhDs. And then finally, the real meat and potatoes or whatever, tempeh and potatoes, if you're a vegan, is the undergraduate research assistants in the lab. That's like, that, I don't know, that's my favorite part of the triangle is all the undergrads. And this is people who, some of you might be research assistants already. At UCSC, you can volunteer or you can also earn course credit. I think it's 194, correct me if I'm wrong, Ezekiel or Amanda or Christy, but you can actually earn course credit for working in a lab. And so that's kind of how it's usually structured in almost any psych lab or really any research-based lab, even outside of psychology. And so this is only my second year. So me, I've got the one grad student, hopefully I'll have 2 more. And right now I've got about 10 or 11 undergrads working in the lab as well. So small but mighty group. I don't want to speak for them if any of them are here, but I would say we have a lot of fun in the lab. We have a lot of spirit in our lab. We're kind of, yeah, a lot of personality, which I like. All right, so let me kind of sort of demystify what this might actually look like concretely, so you can see how an undergrad research assistant plays into the whole research process, and why I put the undergrad research assistants as like the biggest thing, like the widest thing. Yes, there are the most people in the undergraduate research assistants, but also if you think about a triangle, you got to have that most important bottom layer, you're going to topple over. And that's how I feel about undergrad research assistants too, is I couldn't do it without you. So that's why you get the bottom part. Okay, I know there's a lot of writing on here. This is, not the best, but let's start same triangle. What a principal investigator usually does is like, you're kind of the person like in charge. You make everything else go, but really my job is to plan our overarching research projects. Like, what is it that we research in the lab? And then I make sure that we have the resources to do that work, the computers and the money and the participants and whatnot. But then other than that, I just help everyone else learn a lot and then do their best. So here's what people might be responsible for in my lab. These roles do differ a little in different labs, but this is pretty consistent across different labs. So a postdoc, someone who already has their PhD, would work pretty independently to ask research questions, design experiments, analyze data, write papers that relate to the sort of overarching research projects that I, kind of give direction on. And then a graduate student is essentially doing the same thing in the lab, just learning how to do it, getting a little more support. And the goal is, by the time you get your PhD, you're able to do this pretty independently. But at first, you might be just out of undergrad and really learning every step. And then finally, the undergraduate research assistants in the lab, like I said, they make everything go. So you would, often physically carry out the research, right? Participants come into the lab, you tell them, here, go to this computer, it's gonna hear the instructions and the experiment opens up. And then when they're done, you thank them. A lot of times too, undergrads will like make the research materials that people are interacting with. In my lab, the undergrads also program experiments, which I'll show you in a minute. Even help with some data scoring or give some feedback on the project and how we might change it going forward. All right. So I wanted to tell you why how I got into this work. A lot of the research I do is sort of spurred by things I've heard or even thought to myself throughout my education. And here are some of those things. So this one's from me. This is what I often thought in college. Why am I acing math and stats classes and my friends who are just as smart as me, or smarter, let's be honest, are struggling so much? And then how come I can figure out like complicated math, but I cry every time I have to write an essay? Or like, what? I had a C minus, I thought I did pretty well, right? That frustration. Or just another kind of frustration I've had and others have said, like, oh, I worked so hard. I started for like 10 hours for this test. I can't believe I still got a C. And I've also wondered this all the time and had students ask, so how do you actually want me to study for this test? Like there are readings and lectures and homework and I have to figure them out and connect them. Like what am I supposed to do? Or common one I've thought in classes, and I unfortunately think sometimes students have thought too in my classes are, what's going on in this class? You sit through the whole lecture, like, I don't even know what's happening. Or like, I'm supposed to read 60 pages? Like, what am I supposed to get out of this? Like, how do you want me to actually do this? And so these are all some of the frustrations that people experience in school that have inspired my research to figure out how can we alleviate these frustrations so that students are getting the most out of their hard work that they put into school. Because in my experience with like I'm sure over 1,000 students I've taught, probably more than that, there are some who struggle because they don't do the work, but that's a very small number. The rest who struggle, or in either my class or other classes, are genuinely trying their best with the time and resources they have. And so I want to make sure that their effort pays off to help them get the most out of their education. Because what I want is not these frustrations, but rather these more positive, that's taking a while to pop up. We'll speed that along. Nope. There we go. For some reason, the Google Slides was not happy with my internet connection. So here I showed you those sort of frustrations that inspired my research, but I also want to say that there are a lot of really positive, fun experiences about learning in school, and particularly in college. And I want to understand how to help students have more of those things like, I was always the person, front and center in the class raising my hand, but you're in classes, and this may be you, or you may just notice a person in your class who always seems to be really engaged, really interested. Anytime the teacher asks a question, raise your hand. And so how do we help students go from like, what's going on in this class, to being the person who feels confident to answer questions in class? Or like, how do we help students like really understand and be interested in the material? I remember when I was taking a genetics class my senior year of college, just like as an elective, I kept telling my husband, obviously it was not my husband then, like, I learned the coolest thing in my genetics class. And then I would just go on these like long rants telling him about what I learned. And then I would say like, oh, I bet this can explain why. And, we'd start talking about real world applications of it. And yet I also like somehow graduated college without feeling comfortable writing an essay. So it's like, what can explain these moments of frustration and success in school? And how can we help more students have success? And obviously way fewer frustrating moments. So these real world questions are what inspired my research. So let me show you what my research looks like. Overall, the question that my lab is interested in is, how do people learn best? How do they think they learn best? And why do these two things often not line up? And in my lab, we do sort of two related but different types of research. The first is what I call like the in the mind research. It's about the principles of learning and memory. And so what is going on in our minds as we try to learn, understand, remember, and apply information. And that can influence, what you could call the in the world research. This is the applications to teaching and studying in real life. How should teachers teach and students study to maximize real world learning of complex ideas and concepts? And I have the arrows going both ways because it's not the case that I just study principles in the lab and say, here's how we could use it in real life. A lot of times when you study something in the real world, or that's a closer approximation to the real world than most lab studies, things don't turn out as you thought they would turn out, as you expected based on the more fundamental lab research. And that's because the world is complex. Humans are complex, right? There's a lot more that can happen when you stop trying to tightly control everything for a very like foundational lab experiment. And so that's this arrow going backwards, is when things get way more messy and complicated and don't turn out like how you expected in the real world, you say, well, I might need to update my theory of what's actually going on in the mind. And so my lab does both those things. So I'm just going to give you an example of what that might look like, loosely speaking, and then show you exactly how the undergrads have helped with this. Okay. Like I said, as a math major, love researching math. My grad students really interested in math. Here are some things. So this on the left is Wolfram Alpha. We've got Chegg. We've also got photomath on the screen. And these are things, technological advances that allow students to have easy access to solutions to math problems. So you can type in almost like any calculus problem to Wolfram Alpha, and you get a step-by-step solution. Chegg is connected to most textbooks. You can just buy it and get the answers to problems in your textbook. Photomath is taking it a step further. You can literally take a picture of your homework, and then the technology is able to parse the problem and then give you the step-by-step solution. And I think this is super interesting to think about how these technological advances are affecting learning and memory in school. And so I just showed you on the previous slide the structure of the type of research we do. So now let me show you how this sort of real world question inspired the types of research we do in the lab in that framework. So what seeing these different types of apps made me realize, or made me ask, how do students make use of the growing access to on-demand hints and solutions, and how does it affect learning? This one sort of started on the more real world, in the world side, right? I saw these apps were being used in real life. And it made me want to know, when do students look for answers? Like, do they look for them right away? Do they try to solve a problem themselves before looking up the answer? What prompts students to go use these apps? And then how do their behaviors correspond to learning? Do students learn more if they have to try to solve the problem for themselves, or does having access to these answers actually help them learn? Because, a lot of times we don't get the answers to our homework sets, or we may not get them for 2 weeks or something, after it's due. So, this technology may actually be a really helpful thing for students that teachers should be leveraging more. But then, of course, what I'm always interested in is how do we take what we see in the real world and use it to make sense of what's going on in people's minds? Because I just that is my favorite thing about psychology, is you can't peek inside someone's head. I mean, you can do neuroscience research, but at the end of the day, you still have to have creative experiments to try to infer what is going on in someone's mind that produces these really complex things like hint-seeking behavior and learning. So this real world sort of problem made me wonder, why do students behave this way? If they immediately look for an answer, why is that? And then how can we help students make even better use of technology and learn more? And we can't really make these recommendations unless we understand what's going on in the mind. Okay. So let me just give you an example of what this would look like. So here's what we would call a worked example. That's just the term in research. It just means you get to see the answer. So in a worked example, there's the question and you immediately get the step-by-step solution. So if this were in Chegg, you just literally log into Chegg and there's the answer. And the question is it good or bad for learning that students might have access to this? And why is it good or bad for learning? Alternatively, should we force students to engage in problem solving before we let them get access to the answer? Now, granted, we may not have that much control over that, because in real life, there are these growing, improving technologies that make it so even if teachers say, solve it for yourself first, sorry about that. Even if teachers say, solve it for yourself first, they can just, plug it into Wolfram Alpha or something. But the question is, which of these is better for learning? Is it okay to study the answer right away? Or should you try to solve it for yourself first before studying the answer? And if we give students the choice, how soon after the problem is presented will they go looking for the answer? Will they look for the whole answer, or will they ask for just a hint? There's so many interesting questions here. And what I want to know is, what do people do and why, and how does it relate to learning? So here's just sort of an abstract diagram of how this study went. People watched a lesson on compound growth and decay, which was the topic of those problems I just showed you. And then they made some judgments. So this is something my lab's really interested in. It's that component of what do people think is best for learning. These judgments, there was 2 questions. How many problems could you answer correctly on a 10-question test on the materials right now? And how many additional problems would you need to practice to be prepared for that test? Then we gave them practice and had them make the judgments again. And then finally, they took a test either right away or 2 days later. But the practice part is where the experiment happened. Some people were just immediately shown the practice problems with the answers. Some people had to write out their own answer before we let them see the step-by-step solution. So this was something that, takes a lot of people to do. And so I want to show you what the undergraduate research assistants do here. Well, what all of us do. So again, we're back to our triangle. I took out the postdoc. There was no postdoc on this project. So what I wondered, was the big picture research question of, how do students make use of growing access to on-demand hints and solutions, and how does it affect learning? Then a grad student might actually plan this experiment, just like that diagram I showed you, figure out what the experimental conditions we should have are, and then what exactly would happen in those conditions, like what exactly it would look like to participate in that experiment. But then the undergrads came up with the math problems. So they, opened up an Algebra 2 textbook and literally typed out the problems. They also programmed the experiment on the computer so that when participants come into the lab, it's ready for them to do. And then also but pre-COVID, although now we can go back to in-person research, but they would meet participants in the lab and say, hey, thanks for being here. Read this consent form. If you agree to participate, great, come with me. You're going to do a study. It'll take 45 minutes. Here's a calculator and a pencil. I'll be in the other room if you have any questions. And so they actually make the data collection happen as well. So again, undergrad research assistants, bottom of the pyramid, not as in lowest ranked, but as in foundational to getting this work done. And so now I can't help it. I have to show you what happened in this study. Okay. I can't resist a chance to teach. All right, so we had people who could see the answers right away versus people who had to try to solve problems before they could see the answers. And we got to see how much they learned from the test and how well they thought they'd do before the test. Here are the people who just saw the answers right away. They thought they'd get a 9 out of 10 or a 90% on the test. They actually got a 60% on the test. And that was, remember, one of those questions in those gray bubbles that I had earlier in the slides of like, what inspired me to do this research? Myself as a student and some of my students have said, wait, what? I thought I did so much better than that. So this is something we're really interested in understanding. Okay, but what happens if you make people solve a problem first? They can tell exactly how they're going to do. They predicted they'd get a 60 and they actually got a 60. So we see that having to do things for yourself gives you a much better sense of what you know and don't know, so that you at least can judge how well you're going to do on an exam. So 60 may not be what you want, but at least they saw it coming. And this, this is just one experiment, again, that I couldn't do without the undergrads who really made the materials, made it all happen. And then, of course, the whole point of research is that you're just like, okay, now what do I do? Like, so many questions. Why is this? Why were these people so overconfident? Right? That's 3 letter grades overconfident. They thought they'd get an A and they got a D. I think a 60 is a D. But then also there is something really troubling to me, which is, why didn't they learn more? As someone who researches memory, I really, really thought people would learn more trying to solve the problem themselves first. So I have both questions about how people judge their learning and follow-up questions about how learning actually works. So you're not going to see the connection to the next study, but because it's, this was like 2 years ago and the new study is one we're doing now. But this is an example of how we went from sort of a real world problem of like, oh, that's interesting, solving problems didn't actually boost learning, back to sort of the more lab-based why question, that in the mind, what's happening in the mind that makes it so people don't actually learn more by trying to solve a problem. So that led to this overarching research question that we're looking at in so many ways of how do people correct mistakes while they're learning? When is making mistakes beneficial versus harmful for learning? And I got to this question from the math study because what we noticed is that people made a ton of mistakes during the lesson. If we made them engage in problem solving before they saw the answer, they were wrong like more than half the time, right? They got a ton of those practice problems wrong. So my hypothesis was that when you have people try to solve problems before you show them the answer, that may only be beneficial if they have like some idea what they're doing. So I don't know if that's ever happened to you in like a problem solving based class, like math, physics, chemistry, anything like that, where you get a problem wrong, someone shows you how to do it, and you're like, okay, thanks, but I don't really know what's going on. So like you explaining, like the solution still doesn't mean anything to me. So we have a hunch that you kind of have to have some idea of what's going on to correct your mistakes. Otherwise, you make a mistake, someone shows you the answer, and you're like, I still don't get it. So this translated into, through a series of experiments, to something much more basic, to a fun study that was trying to figure out why trying to solve a problem first didn't boost learning. And we want to know, what are the mental processes involved in mistaken formulas, or in applying mistaken formulas or mistaken problem solving strategies? Okay. And it has turned into something very basic as a starting point that my undergrad RAs are working on right now. Are you, Amanda, can you do a thumbs up if you can still see my screen? Perfect. I want to show you that. So LabVanced is the online platform that my lab uses to program experiments so that there's something on the computer for participants to use. And so this is something that my RAs did entirely. I gave them just like the gist of what I wanted in the different conditions. And then I was like, be free. And I helped them learn and gave them resources, but I just really left it to my undergrads to figure out how to do this, and they were incredible. So let's see. So this is kind of the framework that shows all the things that are going to happen in the experiment. And then the RAs have to figure out what it'll actually look like. So I should give you just a brief example. Oops. So they set it up. There's all these things going on. I don't need to explain what they are, but this is how the experiment works. And my undergrads figured all this out. They were amazing. And then this is what it looks like to a participant. This is partway through the experiment. My computer does not want to load pictures and do Google Slides and do Zoom. Can you still see it, Amanda? Okay, great. Okay, what could the price be? $11.18. No, that makes no sense. $118. Ah, $12.09. Okay. I happen to know this is the condition where all the prices are unreasonable. Strawberries, but the participants wouldn't know this. $6.84, I'm going to Whole Foods. $9.49. Okay, hang tight. Okay, $7.67 for sugar. These be them inflation prices. $11.99 for cookies. My waistline would look different for sure. $6.54. $10.59. Okay, so you see the gist of it. And what's happening here is that sometimes people guess before we show them the price, and sometimes they're just shown the price. And the question is, on a test, so I can show you what the test looks like. So we had them learn those prices, and on the test, they just have to remember those prices. So we just show them the picture. And the question is, on the test, are people better able to remember the prices when they had to guess first, or when we went directly to the correct answer and they never guessed? And we think that guessing is good for learning when you kind of know a little bit. So if the prices are unreasonable, guessing is not going to help you because they make no sense to you. And so this is the test. But if you're in the condition where the prices are reasonable, we think that guessing is good. So even though guessing, you're inevitably going to make mistakes, you're never going to guess the exact price. Your guess is still going to be reasonable, right? It's going to be in the ballpark. And so we think that guessing will be good in that case. So mistakes could be good for learning, or they could be bad for learning, depending on how much you kind of already know and how close your guess is. And so my undergrad RAs, they came up with the images and they designed the experiment and they figured out the prices and they wrote all the instructions. Like, they literally did all of this. This was a blank screen. And so they were absolutely incredible. But what I will say is that none of them knew how to do this before the start of the quarter. This was brand new to them. And so they're very handy, but they worked together and figured it out. So just to reiterate what what I did was ask, right, as a principal investigator saying, what does the lab do? I asked, how do people correct mistakes while they're learning? When is making mistakes beneficial versus harmful for learning? I planned the phases of the experiment and what conditions we'd have and what should happen in those conditions. This was just something I'd been wanting to do for a while. So there's no grad student involved in this one. But then I just told the undergrads to do that. And I was like, use grocery prices. It's a long story why, but I had an idea we should use grocery prices. And I just gave them a paper that had used grocery prices before. And I was like, be well, my friends. And they came up with the diagrams. I guess they were pictures, not diagrams, and the prices. They programmed that experiment I showed you. And then they're going to meet with participants in the lab and bring them in and do that. And then probably once we have the data, I'll have them learn how to analyze it and stuff, since they're so skillful. So just to kind of sum up undergrad research assistants, I literally couldn't do it without you. It makes it so much more possible to do tons of experiments and actually carry out the work. There's not enough time in the day for me to do everything. And also having undergrads, at least in my lab, is such a fantastic asset for me since you're the ones who are learning in school right now, right? My research is all about teaching and learning. So it's very handy to have someone who's currently learning because, you know, I don't know, sometimes professors get a little out of touch. So having undergrads is super helpful for the research ideas themselves. And just to reiterate, at least in my lab, you're expected to want to learn. That's kind of your only job. And then my job is to teach you and make sure you have the resources and instructions and opportunity to learn. But it's not like I selected RAs that already knew how to program or already knew a ton about learning and memory. I really just selected RAs who were curious and interested. And one thing I'd say about being an undergrad research assistant is it's a fantastic opportunity if you're interested in grad school to get used to sort of the confusion and discomfort and exploration and discovery of research. Because like things like you think you're almost done with programming the experiment, but you can't figure out one thing and it takes you a week. Or, you know, sometimes you mess up programming. I've done that before and cost your advisor money. Whoops, sorry, Matt Rhodes. And sometimes it goes perfectly and you're super interested and you have tons of follow-up questions. And so I think being an undergrad research assistant is also just a great way to at least start to like inoculate yourself to the emotional roller coaster that is research if you're interested in grad school. So that's what my lab does. And I am ready for any questions.
Thank you so much for sharing your lab and all that information with us. So before we open it up for questions, we have prepared a few questions of our own for Hannah. If you're starting to brainstorm your own questions, feel free to put them in the chat, and then we will get to them later. So Hannah, for the first question, what is research like day to day, and how does that evolve or change from undergrad to graduate school to your position now?
Oh man, every day is one thing I like about being a professor is every day is a little bit different. It's not like you're doing one task over and over again. Like that's what I didn't like about being a statistician is like every day I was just calculating an average, making a graph, calculating another average, making a graph. But in general, every day is just like a little tiny step forward on a big project. You like solve a small programming problem. You figure out which materials you're going to use. You have a conversation with someone else about what the two experimental conditions should be. You find a relevant paper. So it's just every day is sort of chipping away at one of those steps that I've shown you. And it kind of evolves just in terms of undergrad to being a professor of sort of how much it's self-directed. So when you're an undergrad research assistant, you might get instructions like, I want you to make these kinds of materials. I want you to program these conditions to do this thing. And I want you to run participants at these times. Although I definitely try to give like time for a lot of sort of like intellectual independence to the undergrads as well, because y'all have always knocked my socks off with how smart and engaged you are. But it is much more directed. Then in grad school, it's a little bit more up to you to figure out what is that research question? What should those conditions be? How should I interpret this data? Your advisor helps you, but you're learning how to do it by yourself. And then when you become a professor, it's just like, Godspeed, make it work. So you have to do everything from figuring out like, ooh, what do we research? How many grad students do I need? What will be our two projects? This data turned out crappy. Should I try again? Or should I just leave this sort of set of projects behind? How do I teach a second year in undergrad how to program an experiment? Is it better for me to just do it or show them? You know, it's much more, it's almost like at this point though, I feel like a coach. Like sometimes, you know, like a coach will figure out what drills you do and help you improve your technique and things like that and like cheer you on. But the coach doesn't actually play the games. And in a lot of ways, I feel like that's what being a professor is. I'm coaching the grad students and undergrads in the actual games of research, and I'm just here to guide it.
Great, thank you so much. What is a piece of advice for someone who's unsure if they're qualified to apply for research?
Yeah, I think one thing to point out is like everyone feels unqualified to do research. I mean, I still feel unqualified even like to this day, but maybe that's just me. But I've heard that from a lot of my friends, even some of my friends who are like super successful are like have gotten like awards for their research. They're still like, am I dumb? Do I know what I'm doing? But I would say that if you're looking into grad programs to do research, what would make you qualified is, having relatively strong grades in things like research methods and Psych 2, the stats class, having taken maybe some relevant classes, not tons are necessary, but some of those relevant classes. And then also having worked in a research lab is really what's going to help you stand out a little more. And it's not to say the research lab you work in has to be the exact same research as what you go do your PhD in. It's more that having some research experience, even if it's in a different area, like let's say you work in a social psych lab, but then you want to apply to do developmental psychology PhD, having that research experience shows that you understand sort of what the steps are. And like I said, you understand sort of the trials and tribulations of research. So I would say that if you're unsure, just ask yourself, like, do I have those? Did I do okay in those classes? Have I worked in a lab? And is there something I'm interested in researching, right? Am I actually passionate about finding out answers to questions about human psychology? And if you have those things, you're good to go.
Great. And then for our last question, what is your favorite part of your research?
Of my research or of my job?
It could be either, honestly, if you want to talk about your own research or
Yeah.
just anything.
Okay, my favorite part of my job, it's obviously related to research, but my favorite part of my job, like I said, the analogy to being a coach, like, when coaches get really happy when their team wins or something, and like their players have been working so hard and then they finally win a game and do a thing and figure out a play. That's how I feel as a professor. Like when I see students figure out something in programming, or like I can tell they finally figured out how to analyze data, or they have a really good question that helps our research be better. Oh, it's just the best thing in the world. My favorite thing about my research is like, I think it is the most fun puzzle to try to come up with different explanations for what might be happening in someone's mind. So like when I was wondering, that's weird, why don't people learn more when they try to solve a problem first? Asking that question is fun, but then figuring out why it might be and testing different hypotheses is this, like, I don't know, it's almost like a riddle or something of like, okay, you can formulate questions, you have to design an experiment to test them, but you'll never get to know for sure. You'll never get to peek inside someone's head. It's not like you can open their mind and just get the answer. So it's like such a fun puzzle trying to figure out what could be happening and how would I figure that out.
Awesome. Thank you, Hannah. All of those responses are on point, relatable, super helpful. And so we just wanted to open it up to everyone else. If you guys have questions, I see Shelby, you have your hand raised, so you can go ahead and ask your question, and everyone else, you can raise your hands or put it in the chat.
Thank you. I put one in the chat. I've been writing down some questions as you spoke, but the first one is, what classes do you teach at UCSC? That's the one I put in the chat.
Yeah, I teach 129, which is human learning and memory. I always, like every year, I teach a senior seminar related to memory and education. I also teach grad classes, and then when possible, I teach a class called the Science of Learning.
Cool. This one really interesting. The next one is, you mentioned that you did your undergrad in math and statistics.
Yeah. I
suck at math. I literally cannot do calculus, cannot do anything involving numbers. I'm good with like basic statistics. I like excelled in stats too. I thought it was fun, but it's like that was the tip of the iceberg and like math. So I'm just wondering, like, is it super necessary to have lots of math abilities?
No, I literally haven't used any math. The stats is really helpful. And what's helpful about the stats is almost like a way of thinking. Like, it's much easier to design experiments if you also have some understanding of the stats you would use to analyze the data from those experiments. But I would say if you even if you were happy with your grade in stats, but are still like, I'm not sure I totally understand, like I was just figuring it out, that's totally normal. Even though I have a bachelor's degree in statistics, I feel like I'm still learning so much to this day, and that the best way to learn statistics is by doing the research where you would use those statistics. So I wouldn't be discouraged if you had a hard time in research methods or stats, but just know that those are the foundation to help you learn more when you're actually putting it into practice. But I've never used calculus in my life.
Okay. Okay, good. Thank you.
Yeah.
And then I'm seeing some questions in the chat. Audrey, your question will actually be answered on our next slide about where to find research labs or how to volunteer when you're an undergrad. And then Dahlia, your question is, Hannah, are you open to new RAs for next quarter?
That's a good question. I have to look. I don't think for next quarter, but I think for next year. And if I do, I will put that up. One of the peer advisors is going to show you where to find those opportunities. But if you're interested, it would probably be for next year, but feel free to email me and get your name on a wait list.
Yeah, and just bouncing off of that as well, if there is a professor, even if you don't see opportunities in the places that we're going to mention, emailing professors that you're interested in working with is always a good idea, because they might have wait lists for their labs, or they might even have open opportunities that they haven't posted. So that's not a bad idea. And then Shelby said, this is more for peer advisors, but if we do not participate in a research lab, do we have to do one of the 194 courses instead? Shelby, do you mind unmuting and clarifying, do you mean if you don't participate in the research lab, are you asking if there's like other ways to fulfill that intensive psychology requirement?
Yeah, there was a slide a while ago that there was a bunch of 194 courses specific to like cognitive science, developmental science, stuff like that. But I know when you do a research lab, it fulfills a course credit for those. Is it a graduation requirement to take one of the courses if you don't do research?
So for intensive psychology, you're required to take either 2 quarters of research, field study, or senior thesis. And then for the intensive psych major, you're also required to take Psych 181 or Psych 182, and those are like advanced research methods classes. You're only required to take one of those. But if you didn't wish to fulfill that this requirement through research, you can check out like field study opportunities, or you could look into completing a senior thesis if you are a declared intensive major or intensive psych major.
Okay, thank you.
Yeah. And you can always drop into peer advising too if you have further questions about that kind of stuff. Do you guys have any other questions for Hannah that you want to stick in the chat or maybe raise your hand? Let's see. Jay says, if we are near completing our undergrad, are there any careers paid internships for those that will be in graduate school and are interested in pursuing research as a field? Building off of that, how would we go about entering the field through a university as opposed to doing something in the private sector? Hannah, do you know much? Okay, sorry.
Yeah, that's a great question, Jay. So I was actually just talking to Ezekiel about in a meeting a couple weeks ago about working with the peer advisors to get a sort of single one-stop place for y'all to look for these things. Jay, you can always email me. I might have emailed me recently, but I've just started a page that has links to opportunities for people who are post-grad. But I'm trying to figure out a way to make that easy for everyone to access and make it easy to update without that being, my full-time job. But yeah, so there are research positions for students who have graduated with their bachelor's and are hoping to go to grad school, but want a break in between, but still want to participate in research. And so those would usually be something called a lab manager position, where you are kind of in charge of running the undergrad RAs, you're sort of managing them. That's not always what a lab manager does, but The lab manager positions are usually full-time. Like I had a student from my lab who's now a full-time lab manager at UC San Diego. And so that's what you would kind of be looking for, is a full-time lab manager position in a lab at any sort of university. You don't have to be from that university.
Oh, thank you very much. I appreciate it.
Yeah.
Awesome. And yeah, Ezekiel also just followed up, I believe, with Shelby's question, but Psych 194 can also count as an additional psych course for the psychology majors and for cognitive science elective for cog sci majors. So you don't have to be an intensive psych major to participate in research or get credit for it, but it is more of a requirement for intensive psych majors. Awesome. Do we have any other questions just in these last couple of minutes for Hannah? Okay, we can move on, and you guys can stick it in the chat if you have any lingering questions. But we have a few things that we want to leave you with first.
So just a reminder that if you're interested in furthering your experience in the research, we usually post opportunities online in the psych website, as well as the bulletin board outside of the advising office in the second floor of social sciences too.
Yeah, and just to clarify, if you put into Google like psych research UCSC, you should be able to find this page easily. But if not, if you just go to our undergraduate advising page, it should be pretty straightforward on how to find it. But also one last thing we wanted to leave you with, we have a personal testimony from one of our peer advisors that also happens to be in Hannah's Learning and Memory Lab. And I just wanted to read a little bit about her experience, but this is her quote. So, my name is Huda, and I'm a lead peer advisor for the psych department, and I've been an undergraduate research assistant in Hannah's lab since fall 2020. My experience in her lab has been valuable, and it has exposed me to the research process, learning how to conduct literature reviews, design studies, code experiences, and more. Joining a research lab was intimidating at first because of the lack of experience I had going in, but I received constant support and guidance from Hannah and the rest of the team. I think it is an important thing to remember that we all start somewhere, and begin our research and being a research assistant provides that opportunity. And yeah, I think Huda makes a great point that Hannah was speaking to earlier, that everyone is a beginner at some point. And this can be seen as a great opportunity to bond and collaborate with your fellow team members who are also figuring it out. But thank you, Huda, for for letting us say something about your experience. And yeah.
Okay, so we're seeing some questions in the chat. It seems like Professor Hannah has been answering them.
Okay, perfect.
Yeah. So I guess the last thing to say is thank you so much, Hannah Hausman, for the wisdom and the insight you've been sharing with us today. Hopefully everyone has a better idea what to expect for research, and to even see yourself as future researchers. Yeah, thank you so much, and have a great day, everyone.
And thank you all for being here. I hope to see you in person sometime. And I know many of you who are already here, but hope to see more of you.